everyone. I'm very pleased to moderate this second panel dedicated to quantum use cases for industry. And I think we can dive straight away in the discussion. I have one question for three of you. What quantum use case are you currently working or exploring in your organization? I think we can start with you, David. You started at SNCF R&D project previously. Then SNCF Voyageur, Traveler Branch, start a project with Sopra Steria. Can you talk about this new one?
Yeah, it's working. Yeah. First of all, thank you, Fanny, for having us on this roundtable. It's always a pleasure to be here. As you mentioned, this collaboration was undertaken by SNCF Voyageur with Sopra Steria and Candela. And coming back, and we as a research department brought some technological support to this collaboration from the SNCF side. Coming back to your question regarding the use case, the use case that we studied was a classical rail service design problem for high-speed lines. This is a very well-known decision-making problem for railway operator and also for operational research practitioners and researchers. It's a highly combinatorial optimization problem where we must cope with many constraints. For example, the access to the network, the utilization and the capacity management of the train sets. There are various structure of costs which must be handled in this problem. And last but not least, we must also aim at satisfying customers' expectations, in particular in terms of timings and the destination of trains, of course. From our perspective, from the R&D perspective, it's a highly combinatorial problem. This is the kind of problem we like to study, to assess, to benchmark the performance of quantum computing as they exist right now. And so that was a problem that we have studied for some time with classical operation research models and algorithms that were running on classical computers. And we know it is a hard decision-making problem, so that was the main reason for taking this problem with our partners.
Thank you. Vincent, Agnes, you are a techno pusher in innovation, but have you already clear use cases? How do you build your strategy?
Thank you, Fanny. Hello, everyone. Clearly, in the space sector, we are still in an exploratory phase concerning applications of quantum computing. And in fact, CNES has paid attention to this topic for some years now. And by the way, the European Space Agency also studied those potential applications. And to give you an illustration of the large variety of possible use cases, I will mention 4 different use cases that we are currently exploring at CNES. So the first one is in the launcher domain. In order to optimize the trajectory of a rocket during its ascent phase, so it's an optimal control problem, which could lead to minimize fuel consumption and vibrations on the payload. And there is quite advanced work with Sopra and a paper to come at UCAS conference. My second example that we explored also together is about quantum machine learning for Earth observation data. So basically, the aim here would be to detect objects or to classify land use surfaces from satellite images. So here we learned a lot. We conducted several successful experiments on real hardware, such as IBM or Pascal. But there is still a debate on the real potential of QML versus classical AI in this context, since here, ultimately, we would need to scale to large size data, since we want to process images. A third example that we just began to explore, this time with Thales as a subcontractor and Laboratoire d'Optique Atmosphérique. concerns atmospheric radiative transfer inversion. So here, the aim is to understand and to take into account the impact of the atmosphere when we observe the Earth from satellites. And it is a quite computationally complex problem. And my fourth and last example is in fact a chemistry problem. It's about having a better characterization of the spectrum of the SO2 sulfur dioxide molecule. So it's a chemistry problem that is believed to be quite adapted to quantum computing. And even if it is not spatial in itself, it is useful for some future space missions, such as the upcoming Ariel mission, which will want to recover information about the content of the atmosphere of exoplanets observed from a satellite.
Thank you. Charles, is it easy for a company like Sopra Steria to jump with your client in quantum?
In quantum, nothing is easy. And you know that better than I. Nothing is easy. What I would say in preamble is Sopra Steria, as a consulting firm, as an IT services company, we envision the quantum computing for three main purposes. First, simulation, the capability to evaluate millions, billions of options when it comes to simulate the behavior of a complex system. Two, the simulation, the capability to improve the management of millions of resources when it comes to optimize the operation of our clients. And three, breaking security encryption. So the quantum computer is expected to enable breaking security encryption for a lifespan of 5 to 10 years. We support our client to anticipate and to mitigate that risk. So now, if we turn to concrete and tangible projects, so in addition to the four ones that have been already presented by David and Vincent with respectively SNCF Voyager and the CNES, I can share with you two additional use cases. The first one is in the telecom sector. So we have worked with Telefonica Germany on how to improve the traffic routing on a mobile network. So it's not a complex problem, but it's very hard to do it due to the number of network nodes in the network. And you have to have in mind also that 80% of the quality of service issues are due to congestion on the network or lack of capacity. So we have demonstrated that we can better distribute the traffic over a network thanks to a quantum algorithm. In other words, host more clients on the same infrastructure and delay the investment of new capacity. And the second example is about in the defense sector and is about implementing in an hybrid post-quantum cryptography algorithm in one of our products, and following the recent recommendation of the French National Security Agency, ZNC.
Thank you, Charles. Another question. Quantum is still emerging, so why invest and make the move now? Maybe we can start with Vincent.
Thank you. In fact, the space sector is naturally innovation-driven, and CNES, as an agency and a technical expertise center, plays a key role in France in guiding and fostering the development of new technologies that could be useful for space missions. And we also aim at sustaining the competitiveness of our industrial partners and to support their their new ideas and their competence building in subjects such as quantum algorithmics. So in this context where we worked with Sopra and other partners, so in fact it's natural in this context to move forward, even in a prudent manner. If we consider a possible time frame of for possible demonstration of quantum advantage for realistic use cases around 2030. I think that at CNES, for perhaps the 2 or 3 years to come, I think we will continue this approach of exploring several use cases per year. We have still quite a list of subjects to look at with our partners. And I think it's also necessary to assess continuously the potential of the different families of quantum computers, and also to build competencies about different reformulation strategies of our classical problems in a quantum algorithmic context. I think we will implement this approach in order, when breakthrough occurs in the hardware sector, in order to be able to accelerate in this very exciting competition and emulation that we are seeing now.
David, at SNCF, you are in R&D. I think it's obvious, but is it important to start now and not waiting use case really easy for the public?
Well, it's as you said, I am in the R&D department, and it's part of our mission to have an eye on emerging technologies that can help us to have tomorrow better mobility and railway systems. Regarding quantum technologies, it's very important to start right now to bring our own use cases. And you understood that I like difficult optimization problems because these are the ones that we cannot really correctly solve right now in decent computing times. And so these are the kinds of problems that we want to bring to the community. It's also important for us to see the various technologies that are around the field, and there are many of them. This collaboration was gave us the opportunity to have a look at photonic quantum computing. And it's very interesting to figure out the potential of these technologies and to figure out what kind of assumptions we need to tackle our problems. We have a second issue when it comes to go into this field. It's about the building of internal skills regarding the field, and it's also about team education. I will not explain to the audience, but you all know that quantum computing is very specific regarding hardware, software development, and modeling approach. At least it can be quite different from classical approaches. So it's very important to be in this area and to understand the things. And finally, it's very important to be able to anticipate the technologies that can tomorrow bring some big changes in the way we conduct our systems, especially for a system like the railway system, which is a system operating over a long time period. And so it's very, very important to stay focused for this.
Charles, need to comment that.
The standpoint of an IT services company. So our mission is to support the business development of our clients, for which the tech, including the computing, the quantum computing, is compulsorily, obviously, a very, very strong lever. So as far we consider the quantum computing as the next big disruption, the only sensitive option, the only rational option is to invest now and bring the benefits to our customer as soon as possible. So to do so, our investment is threefold. First, Sopra Steria Venture has invested 3 years ago in Quantonation, and so we are indirectly the shareholder of 20 brilliant startups well represented today in that room. And in addition, we have invested in Alice & Bob beginning of that year. The second topic for us, investment, we have built a strong ecosystem around us. Firstly, by leveraging our strategic partner, so AWS, Google, IBM, Microsoft, and last but not least, OVH Cloud. And in addition, we are working a lot closely with shoulder to shoulder with startups, such as Candela for the SNCF project. And the last point, we have developed an offer, the goal of which is to explore the potential of the quantum computing on the core system, on the core business of our clients. And we have just illustrated with the six examples I've shared with you today.
Thank you. Maybe in 1 minute each, can you give me what do you see as the most promising outcome of quantum for your sector? David.
Well, first of all, from what we know now, we still have to wait a little so that we have more powerful machines in terms of number of qubits or in terms of the quality of qubits to be able to handle at scale our industrial use case in optimization. Apart from the use case I mentioned in the first place, I also see some interesting opportunity for challenging real-time decision-making problem when you have to resynchronize or reschedule some resource to take into account the actual capacities, the actual conditions of the systems. From an IT perspective, I think we should also keep an eye on cryptography issues. To be ready when the machines will be there.
Thank you, Vincent.
So regarding quantum algorithmics, as was already mentioned, I cannot say that any quantum advantage has been demonstrated yet in the space sector, to my knowledge. But I believe it will happen in the years to come. But perhaps since I think most speakers here today have focused on quantum computing, I would like to point out another point, which is quantum sensing. And in fact, regarding space missions, we have already seen the emergence of quantum telecommunications, for instance, with space quantum key distribution. And there are also already some projects ongoing that seek to leverage quantum sensing. For instance, a project called Carioca, which will use space quantum cold atom accelerometers in order to measure the Earth gravity field. So definitely, quantum sensing is also a big prospect in the space sector.
Charles, to close this panel.
Yeah, very quickly. So at Soprasteria, we are 60,000 employees, including several hundreds of scientists, of engineers, working on every day, on a daily basis, on optimizing and simulating the most impactful subject of our clients. So we are definitely a leader in the simulation and the optimization. And to us, quantum computing is a strategic lever to go further in these two domains. So increasing of just a few percent, here a problem of fuel consumption, there a problem of network optimization, may have a massive financial savings, may generate a massive competitive advantage.
Thank you very much. I think we have a lot of things to deep dive in the next panel next year, and we see where you arrive. Thank you very much, three of you.
Thank you, Fanny.
Thank you.